It's 3. For 2, because it's reflected upon the white. Because you got to multiply. No.
Thank you.
Reflection multiplied by inches.
Thank you. Thank you. Thank you. All right, we're going to go over these. Yes, every single one of these questions should be somewhere in our notes, are things that we should know. We're going to just spend a few minutes going over these. Hopefully we're all in a similar boat.
Hold on, Jack,
please don't collect the egg.
I'm on the last question, please.
Well, hurry.
I was finishing it up.
Okay, while they're finishing it up, go ahead and get your sheets out from yesterday. We are on the TI-Nspire sheets that talk about translations. There's one that is just translations, one that is just reflections, and one that is just rotations. We should go ahead and have those out. Does it say just translation? No, it says reflections and rotations. That says exploring transformations. There should be 3 sheets, one that is just translations, one that is just reflections, and one that is just rotations. Alright, sorry, I'm collecting.
I'm done.
You said 2 combinations, right?
Yeah.
Really quickly, before we do start going over these, I do want to commend several students that I saw very actively and productively talking throughout it, because I felt like they were helping each other grow and learn. For example, I definitely heard Brooke and Alana talking well. Kelsey and Ren were at least talking some. I didn't get to hear them a ton. Group 2 as a whole, Group 3 as a whole, really talking and collaborating and helping each other learn. Right? There were a handful of others that were talking well about the math. But you're going to learn better, you're going to understand more, and you're going to enjoy the math more when you talk with other people about it. I cannot emphasize that enough. Yes, you will enjoy it more if you talk with people. I know it sounds foreign that you enjoy math, but notice I didn't say you'll love math. I'm just saying when you talk about something, it is way more fun than sitting there silently. And you learn more. And you can go all you want, but it is true, okay? Because legitimately, I saw some students smiling and laughing or giggling in ways, and they were actually talking about the math because I heard it, but they were smiling more than they have in this class in weeks. That's because it is way more fun to talk about something than it is to sit there silently and struggle with it. When you talk with each other, you grow and you learn more. Okay, so this first question, I don't see any points yet. There's some points. Let's see, 9, 10 is what I see for quite a few of us. 9, 9, just one of us. Okay, so we need to be careful about this one. What is the process that we should have used in order to figure out the coordinates after these translations? No one just put something. Say again.
Right, adding and left.
Adding and subtracting. So which one are we supposed to do in this case? Add. Why was it one or both of them?
Both.
Okay, why?
Because
it says units to the right is adding.
So to the right is adding, and up is adding, right? So be careful. 4 plus 5 is 9. 7 plus 3 is 10. All right. That's all we were looking for in that one. Hopefully that one was the super easy one. Here we have a little bit more confusion. And I knew I would have to talk about this one a little bit, so I expected this. Notice it's 3 and then 5. That's where we're starting. I should not have a point there because, well, that's where I started. We should know not to put a point there. From there, I see a 5, 3 here. I see a 5, negative 3. A 3, negative 5. Kind of all over the place. Although I see this common theme of 3s and 5s. So a couple of quick things to discuss here. Negative 5, positive 3. If I went from this starting point to this point, is that a rotation or would that be something else? That to me looks like a reflection. Gentlemen, seriously? Terrence, can you move to group 4, please? I lied. Kaylin, can you move over to group 4? Terrence, stay where you are. This one right here. In the middle.
That ain't work, huh?
What is on your nose, dude? Take it off, throw it in the trash can.
Oh.
Thank you, Kaylin, for maturely moving around the classroom. So, someone already said it. To go from this point down to this point is a what? Reflection, right? We know that, or we should know that it's a reflection because it looks like it's going across the x-axis in what way?
Straight way down.
Perpendicular, and you see how it stayed the same distance to the other side, right? We want to notice, hey, that's a reflection. It stayed, or it was perpendicular, it stayed the same distance to the other side. And it kind of looks like that's what someone was thinking here, is that someone did a reflection in this direction. But it's a rotation. When it's a 90-degree rotation, what is one of the big things we discussed?
The y and x flip.
The y and x are going to flip every single time. Because remember, it's 90 degrees. So when we rotate it, we're going to create that right angle, right? They have to be perpendicular. So the slopes have to be, not for them to be perpendicular, opposite and reciprocal. For it to have perpendicular slopes or lines, they have to be opposite and reciprocal. So the big thing from here, we got two options where the x and the y flipped, right? And even this option of 5, 3, the x and y flipped, but did it go 90 degrees? Could that even be a 90-degree angle?
No.
No, definitely not, right? These give us 90-degree angles. However, which one is correct? How are we supposed to know which quadrant to end in?
The left, top right, left corner, top left corner.
So this direction is clockwise?
No, that's counterclockwise.
That's clockwise.
Remember, it's CW. That means clockwise.
Yeah.
Is that direction clockwise?
No.
This way.
So I needed to go here.
I got that one.
I don't know which one.
Okay? Now please hear me very clearly. This is a little bit harder to do a rotation without a graph. Because I know that the x and y are going to flip, I'm not going to draw the whole graph out, but I might do this. Okay, so 3, 5 would be up here. And I might think in my head, or I might draw it out, that it's going clockwise, so I know it's going to be over here. And if it was 3, 5, I know it's down here, so I know it's going to be 5, 3. And which of those should be negative when I'm in the fourth quadrant?
The y-axis.
Remember, I'm to the right, which I already said earlier is positive or adding. And it's down, so the y is negative. That's how you want to think about this. You can memorize which one becomes positive or which one is the opposite, but that's a lot of work. What is easier to do is if you can remember that the x and the y flip, or, ooh, I don't want to say that. They switch. Why do I not want to say flip?
Yeah.
Because it makes you think
Right, that flip makes me think about a reflection. We're not talking about a reflection, we're talking about that rotation. So the x and the y do switch, but then just pay attention to what quadrant it's in. If it's to the right, the x is positive. If it's down, the y is negative. You have to learn how to picture that or draw something out. Now, could you draw that on your own?
Yeah.
Yes. Could that get tedious, drawing out a graph every time just to do a rotation? Yes. That's why, like, just a rough sketch, like, that's not bad, just drawing horizontal and vertical line and then roughly sketching it out. So, it's your choice how you approach it, but be efficient, be accurate with your responses. Okay, so for the most part, it looks like we were all in one of two places on this question. So we have the point -2, 3, right? -2, and 3 was up here. And it's reflected across the y-axis. This is the tricky part. When it's across the y-axis, which value is affected? The x. You take the opposite, not the negative, the opposite of the x. So if it was -2, 3, the opposite of -2 is Positive 2. So there's my point.
Yeah.
Which all of us at least recognize that it's 2s and 3s, but I do want you to notice, all right, that we are going to have a positive 2, positive 3 for that point. Any questions through these? Okay, before I look at the next page, go to the last question. Anyone want to share with us what we talked about with isometry yesterday? Great question. Matthew.
Alright. It is the what do you call it? Yeah, it's that produces an image that is congruent to the pre-image.
Okay,
So, yeah.
so an isometry produces an image that is what?
Congruent.
Congruent to the pre-image. So, what's another word that I called that isometry yesterday? Does anyone remember?
Rigor.
Not rigor.
Rigid.
Transformation, okay? A rigid transformation, or it's creating a congruent image from the pre-image. And so what is the only isometry that we have formally defined so far?
A translation.
A translation. Yesterday we definitively discussed that a translation, and we saw it, did the side lengths ever change when I translated that figure?
No.
No. Did the angles ever change?
No.
No. Did the area ever change? No. Everything stayed the same, it just was in a different place, but the shape, the everything, even the orientation in a translation stayed the same. That's important to recognize, especially for the next unit we look at. So we are picking back up with reflections and focusing on that today before we get into rotation. So our objectives, right? We need to understand why a reflection is called an isometry. What do you think that's telling me about a reflection? What's it going to do?
It's going to have a congruent pre-image and image.
Okay, so the image is going to be congruent to the pre-image. We want to check to see if that's true. All right? It should be, based on what we discovered yesterday. We're going to try to develop a generalized expression for reflections. So here we are on page 1.2 on the calculator. I assume I need to send this back out.
Yes.
But did we already fill out this table? I know we didn't formally talk about the table, I don't think. Did we fill it out together though?
No.
Did you fill it out? Is there anybody who doesn't have the table filled out in their groups?
Me.
But all the other, so the two people who weren't here yesterday, or I guess Terrence was, but she wasn't writing down. Everyone else has it filled out?
Yeah.
Okay, so tell me what the length of AB was.
5.2
5 point what? 2
centimeters.
centimeters?
Yeah.
And what was A prime, B prime?
5.2 centimeters.
5.2 centimeters. It's on the reflection sheet that I gave you yesterday. It is neither of those. It's the other packet I gave you yesterday. So, what was the measure of angle B?
118 degrees.
It was what?
118 degrees.
Here, 100 and...
18.
Okay, I got multiple people talking.
Oh, sorry.
So let's do this. Lonnie, you started saying first. What did you say?
118.
118 degrees. And Zaria, what was the measure of angle B prime? Same, 118 degrees. Rin?
3.27.
You talking about BC? 3.27?
No, 3.29.
3.29 centimeters?
You wrote.
And then what was B prime, C prime?
3.29.
3.29 centimeters? Last week's, yeah. Alright, what about the area? Some people will be willing to share what we got for the area. Kelsey? You got what? Do you hear me trying to teach? Like, if you want to ask a question, cool, but like, wait until it's an appropriate time.
7.5.
7.5? Nothing else?
I got
I got
7.6.
7.6.
7.6?
7.9.
Mine was moving around a little bit.
Okay. Let's go with 7.6 for now. Was it just 7.6, nothing else?
Centimeters squared.
Centimeters squared. Remember, area is a unit squared. What about for the image?
The
Same thing?
7.6 centimeters squared.
Okay. And then the perimeter.
15.8. 15.8 centimeters.
I'm guessing it was the same for the image?
Yeah.
Okay. So, don't forget one of the big things we talked about, because this freaks some of us out. Can we reflect across a non-horizontal and a non-vertical line?
Of course, it's a line.
Of course, it's a line, right? You just need a line to reflect. We just have to be what to that line? Perpendicular. And it has to be the same distance to either side, right? And that's how we get our image. So you can totally do that. The big thing that we talked about yesterday, I believe, here was number 4, right? Two figures are said to be congruent if they have the same size and same shape. And I redefined that on translations yesterday, and we're going to talk about that some more. So is triangle ABC congruent to triangle A prime, B prime, C prime?
Yes.
Very much so, right?
Because the pre-image and the image map each other.
Okay, and that's what we want to remember, right? We can see right here, and this is what I talked about yesterday, this is what I want you to hold on to. How many angles are there in a triangle?
3.
How many side lengths are there in a triangle?
3.
3. And then there's one area, and there's one perimeter. So that's a lot of things that you would have to check to prove that they are congruent, right? Or we could just do one thing. If we can map one to the other, and they perfectly sit on top of each other, what are they?
Congruent.
Congruent. That's the beauty of understanding transformations well. Are they congruent? Yes. Triangle ABC maps to triangle A prime, B prime, C prime through what? How does it map to it? What is causing that mapping on top of each other?
A reflection.
Through the reflection. That's what we want to notice, right? Maps to triangle A prime, B prime, C prime through the reflection. That transformation, because it's and what's the I word?
Isometry.
Isometry, or the R phrase?
Rigid
Rigid transformation. Because we can do that map, we are going to get congruent figures. Alright? At this point, I do want to give you all some more time to working within your groups to work on 5 through the rest of this. I will go ahead and tell you today that we will finish, or we need to finish the reflections and the rotations. I'm going to send the reflections file back out to you. If we finish the reflections and rotations early, you will actually have a few minutes to work on the homework in class. So I wasn't sure if we would finish, so I didn't plan anything afterwards. So you'll have homework that's due on Friday. So if we work efficiently and get through everything, you get some time to work on homework in class.
Yeah, the ACT thing.
Or if you're a junior, y'all got some ACT stuff you could ask questions about, I guess. Yeah. Alright, any questions on what we're supposed to be working on? We know what we're doing.
Yes, sir.
Okay, so let me send you that file just in case you still need it. We're on the reflections one, right? Alright, let's get to work. You should have it now. You know, we should be working. You have it on your calculators.
That's how I'm sounding to wake up.
We'll read.
Yes, ma'am. Huh? Sorry, I thought you went after you finished your bell ringer.